Hello friend, welcome back to our next video. In the previous video we learned about feature extraction, and we did some of the exercises and the functionality about the feature extraction, and there are basically four things what we did during our feature engineering to extract hour, month, day, hour, then convert our categorical columns into one hot encoding dummy variables. Then we also transformed our target variable, which is count, into log transformation, and then we basically drop some of the columns which is not required. Now in this video we will going to split our training and test data into 70-30, as well as we will going to build and train our model. So let's first go back into ChatGPT and see that whether we are going in the right direction or not. So we can see that the step 2 has been completed based on ChatGPT suggestion, that we have convert dummy variables, our categorical columns, and similarly we have extract some of the hour and the day from the datetime column. Now the step 3 they are suggesting us is to split the data set into two parts, training set and the test set, and the common split is 70-30 or 80-20. So let's go with this 70-30, which is the most standard common way of splitting the data, and let's see what we get from the ChatGPT itself. So what I'm saying is that let's split the df underscore encoded data frame what we have into 70-30 split, where our target variable is let's confirm the name of the column, which is count underscore transform, I guess. Let's confirm on that, which is transform underscore count. Let's paste it here and let's see the code for it. So let's copy the code and let's run it. So let's confirm whether the written code looks to be correct or not. So here it's giving x equal to df underscore encoded dot drop, and it's dropping the two columns. Count basically we don't require, as you know, that is the original value, and the count underscore transform is our transformed target variable, so we are dropping both. And then similarly y is equal to df underscore encoded count underscore transform. So you can see that ChatGPT is very smart enough that this count underscore transform is basically derived from this column count, and it makes sense to drop this column as well from the training data as well. And in the y we are taking the target variable, which is count underscore transform, and then it's splitting based on 70-30. So since it's giving 0.3, which basically means 30% test data, and then random split is 42, and then we are printing the sizes of each of the variable. And we got a error on this one, so let's see the error. So it's saying that count underscore transform not found in access. So let's see why. So basically actually we have gave the wrong name, which is transform underscore count. So let's update the code and let's rerun it. And now after running the code, we have got the training x underscore train shape is 7620 rows and 16 columns, whereas x underscore test has 3266 rows and 16 columns, and similarly for our the y variables as well. So this looks to be good. We have split our data now. So now let's build our regression models. So for that, I'm choosing a model called XGBoost. So let me copy this one and then paste it. Now I'm telling to ChatGPT is now let's build a regression model using XGBoost and use some common and popular hyperparameters. And I also mentioned that use we can use grid search as well to find optimal hyperparameters, optimal hyperparameters. So it has started. So using the grid search CV method to find the optimal hyperparameters. So let's run this command, and let's copy the next part, which is, so it's using 6 hyperparameters and these are the possible values it's giving. So let's copy this code. What for this exercise, ChatGPT has suggested to use some of the popular hyperparameter, these 6 ones, but for this exercise, for this video sake or for this course perspective, I am taking only the first 3, the learning rate, number of estimators and max depth. So I'm removing the other 3 ones, and then it using the XGB regressor which we need. I can paste it here as well. And then let's copy this code where is initializing the grid search, and then fit the model and perform grid search. And then copy this code further. Now this statement basically will print the best parameters it has got from the grid search CV functionality. So we can also print what exactly they have received. And then this part is done, and let's copy this part. And then finally they are evaluating the performance of the model using R squared and mean absolute error, mean squared error and mean absolute error. So what they are doing is that they had defined the 3 parameters, and they are giving the values 0.01, 0.1 and so on. And then we will use the grid search functionality to figure it out which combination looks to be the best, and they will going to evaluate based on this scoring pattern. Once they figure it out the best hyperparameters, then those best hyperparameters will be feed into this training model. So that's where the real training will start based on the best chosen hyperparameters from the top code. So let's run, and it will going to take some time. It might take like 5 to 10 minutes depending upon your speed of your computer or the computational power, because we are doing a lot of different combinations here. So it will take 10 to 15 minutes to complete this code. So let's run this code. So the model has been successfully ran, and let's see what best parameters it has chosen here. So we can see that number of estimator they have chosen to be the 300 for training the model. Similarly, the max depth they have chosen 5, and we can confirm by let's print the command here. So when we print here, let's copy this best params, and we can see that the best estimator learning rate they have chosen 0.1, 0.1, max depth 5 and number of estimators 300. So, and now the results have been come. We have got mean squared error to be 0.09, which is like 9%, mean absolute error to be 0.2, which looks to be little high, 20%, and the R squared values coming to be 0.95, which is very good. To be honest, 95%, getting 95% is really good. Now the next thing what I want to see in this calculation, now I want to compare about over prediction and under prediction, because that is also very important in regression. You don't want all the predicted values to be either under predicted or over predicted. We want something to be a very normal distributed of residuals, that some values are under predicted and some values are over predicted and some are exactly overlapping between test and train error. We don't want all the values, all the predicted values have been over predict or under predict. So for that, let's ask ChatGPT if they can write the code to compare our over prediction and under prediction. So let's ask write a code or a histogram to compare our prediction and under prediction on prediction values. So let's copy this code and see the results. So we got an error here, and the error so actually we need to use y underscore predict. So let's replace here and let's see if there is any other place. So now when we plot this graph, we can see that most of the our residuals, or or the error between actual values and the predicted values lies very close to zero, and some of the values are going on the left side, which shows that we have some under predictions, and some are going under predictions, over predictions as well. So it means that our values looks to be very close to that zero value. So they are looks to be a very good bell curve or a normal distribution, and that's exactly what we are looking for that. So this shows that our model has learned both under predictions and over predictions as well. And the last one thing which I want to check from this, the performance of the model, is using the cross validation as well. So let's ask ChatGPT to write a code for cross validation. So can we write the code for tenfold cross validation? So it's have started writing the code for it. So let's go and see the results. And it's taking tenfold cross validation, and the scoring pattern, it's using the R2 squared or R squared values. And let's see. So we can see that mean R squared value across 10 different iterations coming to be 95%, and standard deviation, which is, so it looks like in every iteration the R squared values looks to be very close. So what one more thing we can do is to see in every iteration what root mean square error and the R squared values we are coming. So let's ask from ChatGPT to print those results as well. So let's go back to ChatGPT and ask that ChatGPT, in this code, print the R squared and root mean square error for each cross validation round as well, and print their values. So let's copy this code and then print it here. And now we can see for every iteration R squared value and the root mean square value. So we can say that we can see that R squared value looks to be very close to 95%, but our root mean square value is coming to be around 28%, 30%, and so on. So we can see that final root mean values coming to be 31%, as well as the root mean square error values coming to be mean values 0.95, and these are all the results for it as well. So this is how we can build our model. We can evaluate the performance of the model with the help of a ChatGPT, and you can see that ChatGPT is doing a really good job in helping in building the code, building the model, doing some of the important feature engineering and the feature exploration step as well. So let's do next step is to find the feature ranking as well, because we want to know which features are contributing to the most. So like find the feature ranking. So let's copy this code, and now this code, this set of line will tell me the feature importance as well. And we can see that our to be the most important feature, which is 0.44, and which makes sense because during our exploration part as well, we saw that our plays an important role, especially in the morning 6 to 8, and then in the afternoon or evening around 5 to 7 or 4 to 6 something. And then year also makes a lot of, year is coming to be second important, working day, then month, weather, temperature, holiday, humidity, and so on. So we can see that a lot of the things which we learned during our exploration part, which is making a lot of sense in the feature ranking part. So in the next video, what we will going to do is to consolidate and compile all the results what we have got, and then we will hand it over to ChatGPT, and then we will going to ask ChatGPT if they can outline or create like a 1-pager report or a 2-pager report, so that we can share all those results to our stakeholders, to our managers, so that we can explain each and everything to them. So stay tuned for the next one, and I will catch you over there. Thank you.